Hello everybody! Today we are going to be building the basic shell of a Tycoon game. So a Tycoon game is a small business simulator, and in this example I'm going to be building a simulator of Lemonade Tycoon. I like Lemonade Tycoon because it's a simple example because it has very few ingredients and only one product that you can make. All right, so what we're going to do here is I'm going to start off by just making it pretty simple. We're going to go with the basic shell of the game. And then after that, what we can do is we can move on and talk about how we can add different upgrades and different things to the game. Now, this will be built out of the console, so it's not going to be graphical, but once you kind of learn graphics, you'll find that tying the components that you're building to the graphics is not really that hard. So like it's really kind of what happens when you press that button or when you update that display that's really important, right? And so by doing what we're going to do today, we're going to cover all the basics, and then later on, if you learn graphics, you can put it all together. Okay, so before we begin, we need to know a few things. All right, so I'm just going to put this in a comment here because this is going to kind of guide us here. We have our ingredients. Okay, so our ingredients are going to be lemons, sugar, cups, and ice cubes. All right. The recipe that we're going to have, and I actually picked this up from a place online, is a 1.75 cups of sugar. We need 1.5 cups of lemon juice. Okay, we'll talk about how to get that in a minute. 8 cups of water and 16. Well, we need basically 2 cups or 2 ice cubes per cup. So if we have 1.5 cups of lemon juice and 8 cups of water and whatever sugar, we're making approximately 10 cups of lemon juice, of lemonade. So for that, we're going to need 20 ice cubes. Actually, and we won't need 8 cups. We will need, yeah, we will need 8 cups of water, but we will actually need 10 cups. Right, so 1 cup for each cup of finished lemonade that we're going to be making. All right, now this 8 cups of water is not going to be included because in the game we're going to assume that the water is free, and so you can have an unlimited amount. But so essentially we're going to have 1.75 cups sugar, 1.5 cups lemon juice, 20 ice cubes, and 10. That will make 10 cups of water, of lemonade. Okay, now I also looked up some costs. Now, right now, as I'm writing this, we are in quarantine from coronavirus or isolation, and so the prices might not reflect the actual costs of things, but as of today, the cost of things are 0.44 cents for a lemon. All right, about 3 cents for an ice cube. Okay, 22.4 cents. For cups, and well, we can actually just put that 23 cents for cups. All right, and then our sugar is 28 cents per cup. All right, let's see, so 0.28 per cup sugar. All right, so once we have this, then we can start kind of coding things together here. Oh, we also need one more conversion, is that essentially 1 lemon is actually in real life can yield 2 tablespoons of lemon juice, but what we're going to say at first is equal to 1 tablespoon of lemon juice. All right, so basically we're going to need, and then how many tablespoons is in 1.5 cups? Well, there is 16 tablespoons in equals 1 cup. All right, so that means we need 16 lemons for 1 cup, or 24 lemons per recipe. All right, so okay. So what we're going to do is we're going to start off by declaring some variables for our inventory. All right. So what we're going to need is some integers. So integer, lemons, cups, ice cubes, and sugar. Now, sugar probably should not be an integer, mainly because if sugar is an integer, because we're not actually using it as because the recipe requires 1.75, right? We're not really using it as an integer, all right? So we'll make that a double, okay? So equals 0. Okay, so we have 0 to start everything here. Okay, now for our doubles, we're going to have sugar as a double. And then we will also have, sorry, I should be consistent with my formatting here. This doesn't actually matter for your code, but I think it looks nicer like this. Okay, so sugar and money. Now, here's the thing. How much money should you start with? Maybe something like $40. All right, so we got something like that. Okay, so what we're going to do then is we're going to also have to set the prices of things. So we can say constant double lemon cost is equal to 0.44. Ice cube cost is equal to 0.03. Cup cost is equal to 0.23. Okay, and sugar cost is equal to 0.28 per cup. All right. So those are going to be our costs that are going to be associated with the game. All right, now we have our variables set. What we're going to do is we're going to have to find a way to verify them. So we're going to write out just a little bit of code to show an inventory. All right, so see out something like Lemonade Tycoon. All right, and let's put a few tabs there, and then an end line. Okay, so for those of you who don't know, a \t when placed into a string makes a tab. A \n makes an end line character. All right, so see out, and then we'll just put like a big line like that. Let's see if it looks right, or if the line needs to be longer. Oh yeah, the line needs to be a little bit longer, or maybe we just don't need so many tabs. Let's try that. Oh, that actually looks pretty good. Maybe one more there. All right, great. Okay, so what we'll do is we'll say start listing our inventory. So lemons, tab, lemons, end line, sugar, tab, sugar, end line, cups, tab. Probably don't need that space there. Okay, and cups, end line, and then ice cubes. Now, ice cubes might not need a tab. We'll try it out and see where it goes, just because the word is so much longer than the other words. Okay, let's see what we got. It should be everything 0 right now. Yeah, I figured ice cubes is a little bit too high, but what we can do is we'll just add an extra tab onto the rest, right, to help line up those figures there. All right, there we go. And we'll need a last one to show our money. Money. Okay, and money. Now, because we're dealing with like fractions and stuff like that, we might end up with our doubles being represented with things that are like 0.4529 or something like that, which we probably don't want. All right, so let's push this out a bit. So another tab there, make sure it all lines up. Probably need another tab. There we go. Okay, so what we're going to do is we are going to set our precision. So we're going to say set precision to be 2 and put it fixed like that. All right, and let's just try it out. We'll put our money as 40.12345 and see how it looks. Of course, because we have to import the library, hash include. I believe this is an IO manip. Yeah, there we go. So the 40.12345 actually appears like that. And the sugar also will need that as well. Okay, so because sugar is also a double. All right. So far, everything looks pretty good. Everything else it makes sense to have as kind of an integer, because sugar is the only one that doesn't have to be like that you can take a fraction of. Like you can take part of a cup of sugar, but it doesn't make sense that you would take part of a lemon, right? Or half of a cup or half of an ice cube. All right. Okay. Now what we're going to do here is we're going to just put a few more, one more end line here to make some space. And then what we're going to do is set up our main menu. All right, so we're going to say cout main menu. And then what we'll do for consistency is copy this line so it looks the same as the one above it. Okay, probably make a tab here so it matches the menu on top. We want it to look consistent. Okay, so there we go. It looks pretty good. And then what we'll do is we'll add items here. Okay, so we are at first only going to add like maybe 3 items. Okay, but the first one we're going to add is 0, exit the game. All right, so what we're going to do is give the person a chance to exit the game. Okay, and the reason why I chose 0 is because if we put 1 to, like usually you want the last item to be exit the game, but then whenever you add an item, you have to keep pushing exit the game. It just makes you have to recode this over and over again. By setting 0 to be exit the game, you make it so you can just add things after the menu, and also that 0 on the keyboard is farther away from the other numbers, and so it's less likely to be inadvertently pressed. Okay, so then what we're going to do is up here we'll say int main menu choice. Okay, we're going to just set up a main menu choice. So we'll say cout exit the game, cout what would you like to do, and no end line, cin main menu choice. All right, now this is a very, very important part here. Okay, so what we're going to do is we are going to set up what's called the main game loop. All right, the main game loop is essentially how the whole game cycles around over and over again. If you notice most games, like basically they show you something, then you do something, and then it updates what it's showing you. And that pretty much like every single game runs like that, right? And so basically the way they achieve that is by doing a main game loop. Okay, so what we're going to do is we're going to say do this. Okay, so we're going to put the whole game into this main game loop. All right, and then what we're going to do is say while main menu choice does not equal to 0. All right, so when I show you what happens here, okay, so we got what would you like to do? 1. Okay, you see it went back to the game loop. 2, 3. Now we got the menu constantly like scrolling up, and I don't really like that. So I am going to use now system CLS to clear the screen. All right, and I'll put a comment here. This can only be used in Windows. Okay, no iOS. All right, because this is a Windows command, and because it's a Windows command, I have to hash include windows.h. Okay, so when I go to 0, exit the game. All right, okay, just exit it out of the main game loop. And when I press anything else, You can see it clears the screen and just takes me back to the main game loop. Okay, great. So what we'll do then is we'll add something else. Okay, so we're going to say cout 1. And first thing we're going to need to do is we're going to have to be able to purchase something. So go to the store. Okay, and here I'll put an end line to create some spacing. Okay, there we go. So go to the store. Now when I press 1, we don't actually go to the store because we haven't written that code yet. Okay, so down here, I don't know why that didn't type anything, but okay. Okay, so now here, what we're going to do is I'm going to put a to do here. Okay, we should put a type trap here or an error trap here. Okay, to make sure that the input is actually error trap, but for now we don't really need it. Okay, so what I'm going to do is I'm going to say if the main menu choice was equal to 1, that means go to the store. Okay, this means they want to go to the store. Okay, so what we're going to do is we are actually going to build a store. Okay, so the store is going to look very much like the main menu. All right, so I'm going to copy everything from the main menu like that. Okay, except here where it says main menu, what I'll do is I'll call it, I don't know, Linus's Lemon Lab. All right, something like that. Okay, so because we have the clear screen now, when we go to the store, it's going to clear the screen. All right, and you can see very quickly it went to the lab, but then it just cycled back to the main game loop. All right, what we have to do is we actually have to do a store loop. Okay, so we're going to say do. And in the same way that we have the main game loop, we're going to keep looping around, okay, while, okay, and the variable we're going to use is called the store choice. Okay, so what we'll do is we'll say like something like this, cout 0, to keep it consistent, exit the store. Cout. What would you like to do? Cin store choice. Okay, and this while loop will say while store choice is not equal to 0. Okay, so you can see the main game loop is checking to the main menu choice. Okay, so what happens is if they enter anything except for 0, it will come here, and if it's not 0, it loops back to them. It clears the screen, loops back, and then clears the screen, shows the main menu and everything again. If we choose 1, then what happens is we fall into this do while again, another loop. Okay, so in this one, we clear the screen, and it's exactly like the main game loop, except now we're trapped in this loop. Okay, so we're going to clear the screen, show the inventory again. Okay, change the menu, so exit the store. What would you like to do? And if they don't choose to exit the store, this will take them back up to the beginning of the store again with the updated, and it'll update their inventory every single time. Okay, so I'll show you what I mean. So here, if I go 1, go to the store. Okay, now I'm in Linus's Lemon Lab. Okay, I can choose 1, 2, 3, 4, 5, 6, 7, 8, 9. As soon as I choose 0, okay, it's going to take me back to the main menu. All right, and here, so I can go into the store, main menu, back into the store, main menu. Okay, and when I choose 0, then I exit the game. Okay, and that's essentially how we're going to just run things. Okay, so what we're going to do is we're going to add in some options. Okay, so we're going to say buy lemons. Okay, and the lemon cost okay, we're going to show the lemon cost there. Now, the reason why we program these with variables instead of just hard coding them with numbers is that later on, if we need to tweak those numbers or change them in some way, then we can just change it up at the top here where they're set instead of having to look for every instance of this variable or that number occurring throughout the program. Okay, so we're going to say buy lemons. Okay, lemon cost. Okay, and that's it. All right. Now, once we have the store choice, we can use another if statement. So we can say if the store choice was equal to 1, that means buy lemons. All right. So how do we do this? Okay, so we're going to start off by saying something like, how many would you like to buy? Okay, now we don't want to force the player to have to keep choosing buy lemons one at a time because that's just going to like make them upset, right? It's going to be super boring, especially if you need to buy like 50 lemons. Okay, like just to make 1 cup of lemonade, you need 24 of them, which would mean that you'd have to go like and actually create like you'd have to go and like buy 24 lemons like, you know, one at a time. It would just be a pain. So we're not going to do that. We're going to say how many would you like to buy? Okay, instead, so in order to do that, we need a variable called quantity. Okay, so how many would you like to buy? Cn quantity. All right, and at its simplest, what we'll do is we'll say after they enter the quantity, then lemons is equal to lemons plus quantity. All right. Now, there's a shortcut way of saying this is lemons plus equals quantity. All right, so we can do it that way. I will leave this in here just so you can see. This does the same as the line below. All right. So we're going to say lemons equals plus equals quantity. So we're going to add that. So if I bought 10 lemons, then I'm going to add 10 to my lemons. Okay, and then money minus equals. Okay, so how much do we take away? Well, it's going to be the quantity times the lemon cost. Okay, so the unit cost of the lemons. All right, now there is going to be a slight problem that can arise from this, and we'll go over it in a minute, but we will just take a look and make sure this works here. Okay, so here we go. So I'm going to go to the store. I want to buy lemons, and let's just buy, I don't know, 24 lemons. Okay, so we have 24 lemons now, and looks like my money went down probably about the right amount. Okay, so they're about 40 something cents per lemon. Let's see, yeah, lemon cost is 44 cents per lemon. Also, my money was messed up because that's from my earlier testing. Okay, so if we buy 10, our money should go down by $4.40. So let's go buy 10 lemons. Oh, what would you like to do? 1. Okay, buy 10. Okay, so now I have 10 lemons, and yeah, my money went down by $4.40. Okay. Now, the problem is that we can do some wacky things with this. So for instance, I could choose to buy, so I'm going to buy lemons, and I could choose to buy like -10, okay, and like sell them back, right? Normally a grocery store wouldn't allow you to sell things back, but it gets worse than that. I could choose buy and buy a -10 again, okay, and get $4.40. So if the goal of your game, for instance, is to make like $10,000, then they could just sell 1,000,000 lemons and get that instantly. So you want to make sure that the user can't do that. Also, right now, I could choose to buy lemons, and I could choose to buy like 10,000 lemons, okay, and it'll give it to me, but my money will go negative. Okay, I don't want to be able to do that either. Okay, so what I have to do is I have to actually put in an error trap here in order to fix that, to prevent my user from doing this. Okay, I'm just going to do a simple one here. Okay, so we're going to put this command into a do while, and what we're going to do is we're going to say oops, this does not go in here. Right, because we don't actually want to take away or add lemons or take away money until we actually have determined that the quantity is correct. Okay, so while quantity, so we're going to repeat this while quantity is less than 0 or money is less than the quantity times the lemon cost. All right, so this means they chose a negative amount, and this means that they have they don't have enough money to buy what they wanted. All right, so let's take a look. What would you like to buy? Go to the store. Okay, buy lemons. Let's try and buy 1,000,000 or 100,000. Okay, doesn't let me. -9 doesn't let me. Just how about 24 lemons? Okay, so it's about $10 for 24 lemons, and there we go. All right, so that seems about right. Okay, so what we would need to do then is actually just complete the rest of the inventory. Now, I'm not going to do that in this example. I will leave this as a to-do. Complete the rest of the purchasing. Okay, now the problem is I can't really move forward in the game, right, without being able to purchase the rest of the things, right? So what I'm going to need to do is come up with a way to get inventory without actually doing anything else, like without having to go and program the rest of this. All right, so there's an easy way to do that. So here's the end of, this is the if statement that takes you to the store. Okay, you can see here it goes to the end of the if statement. All right, and now it's very important when you're coding to keep all of your brackets like in order. Okay, now the convention, okay, just so you know, is actually to have it written like this, with the opening bracket beside the command and the closed bracket lined up vertically with the command. Okay, but for beginners, I found that it's easier for them to see the commands, like see the scope like this. All right, so I would just leave it like this. All right, but I don't actually care. However you write it, it's up to you. Okay, but this is the end of the if statement. Okay, so that means what we're going to do is we're going to make another if statement. Okay, I'm going to say if main menu choice is equal to, I don't know, let's choose, I don't know, 1, 2, 3, 4, 5. Okay, just something simple like that. And what we are going to do is, like, this will not be actually listed in the main menu at all. But what it will do is we will say lemons equals or plus equals 100, sugar plus equals 100, cups plus equals 100, ice cubes plus equals 100. Okay, and we'll say money plus equals, let's give ourselves $100 as well. Okay, so what that does is it actually adds 100 of everything to our inventory if we type 1, 2, 3, 4, 5 at the main menu. And what this is known as is a cheat code. All right. Now, what cheat codes really are is there are ways for a programmer to actually test the code without actually having to play the game, right? Because either because the code is not finished, as in our case, or because you don't want, it's just really laborious to have to play the game. All right, so we're going to do 1, 2, 3, 4, 5. Okay, you can see now I've got 100 of everything. And now I can work on something else besides going to the store. All right, so you can add your own cheat code if you want. Okay, this actually should be an else if, right? Because if it goes to the first one, it's not going to go to the second one. Okay, and then what we're going to do is add another else if. So for each main menu item, we're going to say, we're going to have to make an if statement where main menu choice is equal to 2. Okay, so what should number 2 be? Okay, so I think number 2 should be, let's say, well, yeah, we can always change it later. So start the day. Oh, haha, I put this in the wrong spot. This is actually in the store. So please don't make that mistake, all right? Because it's very easy to get like your scopes mixed up, just like I just did right there. Okay, so we're going to go up here and say cout start the day. Okay, /n, go down. I just noticed that this is not consistent with the menu look up top. Okay, so what do you want to do? So one is go to the store. Okay, I'm just going to leave without buying anything. 1, 2, 3, 4, 5. Okay, get 100 of everything and start the day. I don't like how this 2 appears right beside this question mark, so I'll add a space there later. Okay, and right now it doesn't do anything because we haven't built that yet. Okay, so what do we do when we start the day? All right, so this is where things get a little bit tricky. So we're going to have to start by determining the number of customers that come during the day. So what we're going to need is a minimum and maximum number of customers. All right, so we're going to go to the top here and we'll just add that in. Customer min. Now we're going to say customer min is 0 because there could be no customers that day. And we'll say customer max is equal to, let's say at most you get 20 people. All right, so what we'll do here is we will randomly determine the number of customers that are going to appear. Okay, so we'll have number of customers is equal to rand modulus customer max minus customer min plus 1 plus customer min. Now, I know a lot of people are going to call me out on this, saying that there's a 0 here, so why do I even put it? It's because later on we might get things that would change our minimum customers down to be so that it's not 0. It might move it up to 1 or whatever, right? So in any case, what we're going to do is we're going to generate the number of customers for the day. And what I will do is just test this out. So cout number, customers, number of customers, end line, put a system pause here. All right, and we should just be able to see how many customers we get. So if I just go 1, 2, 3, 4, 5, start the day. Okay, I got 20 customers that day. Start the day, 8, 13. Okay, so it looks like it's working. Although these numbers are always pretty high. Oh, there we go, 0. Okay, good. Just a random number generators being lucky to whoever's playing at this time. All right, so what we are doing is we are generating customers, but so far we're not doing anything with them. All right, so what we're going to do though is we are going to go and we have to create a jug of lemonade for each one of the customers that we have. Okay, so what we're going to do is we're going to have int servings. Now a jug, we said, is going to hold 10 servings, right? So where is it here? So we said with our recipe, yeah, we have 4 cups of water, or 8 cups of water, plus ice cubes and everything. So about 10 jugs, or 10 cups of lemonade per jug. Okay, so int servings is equal to 0. Okay, now what I'm going to do is I'm going to say, as long as the number of customers is greater than 0. Okay, and what that means is as long as there's someone wanting to buy the lemonade. Okay, and okay, now what we're going to have to do is we're going to have to grab our recipe from here. We're going to say 1.75 cups of sugar. Let's actually just copy this down so I don't have to keep going back up. Okay, and so our sugar is greater than or equal to 1.75, and cups is greater than 10, and actually you don't need the cups just yet. Sorry, so sugar is greater than 1.75. We need 1.5 cups of lemon juice. So, and we said that 1 lemon can, where do we have it here? And oh yeah, we do. There it is. So 16 tablespoons, so 24 lemons per recipe. Okay, and so lemons is, did I put sugar with a E? Sugar. Okay, so we said that we would need 24 lemons. So 24 lemons and ice cubes is greater. Actually, we'll just leave it. So what we have here is we have enough sugar and we have enough lemons to actually make the lemonade. Okay, so we have customers and we have enough sugar and enough lemons to make the lemonade. So then what we're going to do is we are going to say, we're going to start serving customers. All right. So what we'll say though is we're going to check here, and first thing we'll do is we'll say if, so we got to check, do we have cups and do we have ice cubes? So if cups is less than or is less than or it can never equal 0, but let's just say if cups is equal to 0 or ice cubes is less than or equal or less than 2. Okay, so meaning that we need at least 2 ice cubes in order to serve 2 ice cubes and a cup to serve the customer. So if we are out of those, okay, then we can't serve them. Right? So what we're going to do, I'll put a comment here. Checking to see if there are customers and we have ingredients to make lemonade. Okay, so if we have cups, then if the cups is equal to 0 or ice cubes is less than 2, then what we're going to do is we're going to say, well, we can't serve anybody today. So the number of customers is equal to 0. Okay, and we'll just break. Okay, so we're just going to break out of this loop because we can't serve anyone anyways. Okay, let me just write that in a comment here. If we don't have enough cups or ice cubes, we cannot serve anyone today. Okay, so what if we can? Okay, so else. Okay, so what do we do? Okay, so this means we can serve someone today. Okay, so we have to make a jug of lemonade. So we're going to make a jug of lemonade. All right, in order to make the jug of lemonade, what we're going to do is we're going to have sugar minus equals 1.75. Okay, so then we're going to take away 1.75 from sugar, and lemons minus equals 24, so we're going to take away 24 lemons. Okay, now what we're going to do is we're going to put another while loop. Oh, sorry, we're going to say servings is equal to, and we said we would make 10. Okay, so what we did is we converted 1.75 cups of sugar and 24 lemons into 10 servings of lemonade. Okay, and then we're going to say while the number of customers is greater than 0, so now while we still have customers, and cups is greater than 0, and ice cubes is greater than 2. Okay, so now what we have is enough to assemble a cup. Oops. We have enough to assemble a cup. Oh, and servings is greater than 0. Okay, so we still have servings. So what we're going to do is we will say, okay, cups minus minus, so we're going to take away a cup. Ice cubes minus equals 2. We're going to take away 2 ice cubes. We are going to take away a serving out of our jug. All right, and then what we'll do is the number of customers will also go down. Okay, so what we do here is take away a cup, take away 2 ice cubes. All right, take 1 serving from the jug. All right, and take 1 customer out of line. All right, so now we've served 1 customer. So what we do then is we say, in exchange, money plus equals. So money is we're gonna add some money on. And do we have a cost yet? Let's see here. Price? Nope. Okay. What we'll do is we'll just say double price is equal to, I don't know. Let's set it to be 1.5. Okay, $1.50 per cup. All right. We might have to tweak that a bit to figure out like exactly how much everything costs, right? And if that actually makes sense. But let's just put it in there for now. Money, you add the price to the money. Okay, so what's going to happen here is one of these is going to run out. We're going to either run out of cups, run out of ice cubes, run out of servings, or run out of customers. Okay, whenever that happens, as long as that doesn't happen, we will keep selling our servings. Now, what happens if the servings runs out? Servings will run out. We'll come to the end of this else, right? Which will take us out into this while loop, and we will come back into this while loop here, and we'll say if our number of customers is greater than 0, right? So we're going to check, do we have customers? Yes, right? So we're assuming we ran out of servings. Check if we still have customers. Check if we still have enough sugar, enough lemons, right? This will not happen, or this does not happen in this example. Then if we have enough stuff, then what we do is we make another 10 servings and we keep serving. All right. Now, what if we ran out of customers? If we ran out of customers, we're going to still come out of this while loop, come out of this else, go into the while, and the number of customers will not be greater than 0, so the day will just end. Okay. What if we didn't have enough cups? Right. So if we didn't have enough cups, then we would finish this, finish the else, go back out to the while, come back up here. Now, what we would have here, we might still have enough, but we would check and we'd see we don't have enough cups. Same thing with ice cubes. And then the number of customers would be set to 0, and we break out of this loop and end the day. All right. So that actually should work there. All right, let's take a look. Let's try it out and see what happens. And what happened here? Ice cubers. There we go. All right, so 1, 2, 3, 4, 5. Okay, we're going to start the day. 2. Okay, now it just did something, right? It didn't really like help us out here very much. Okay, so let's go and print out some things. Okay, so cout, you had, actually, yeah, okay, so you had number of customers today. All right, and what we'll do is we'll keep track of how many were served. So we'll set it to be 0 here. And then every time we serve a customer, we will just add it up. So customers served plus plus. Okay, and at the end of the day here, we can say something like, you were able to serve customers served customers. Okay, that looks pretty good. Just wanted to change one thing that's been kind of bothering me here, just a space. All right, and let's see what happens. And customer served not declared in this scope. And why not? Oh, no, that should be okay. Customer served in which scope? Let's see. Oh, because I don't need to say int again. There we go. Okay, so what we're going to do is we are going to just start the day with no money. It should say we have customers, but we were able to serve 0 of them. Of course, it resets the screen. Let's put that system pause back in. All right, so start the day. You had 20 today. You were able to serve 0 customers. Okay, so 1, 2, 3, 4, 5. Okay, let's start the day. You had 8 today. You were able to serve 8 customers. All 8. Okay, so what should happen? Our money, it should go up by $12, right, for serving 8 customers because we've got $1.50 each, right? Our lemons should have gone down by 24, so this should go to 76. Yeah, sugar went down by 1.75. Now we lost 8 cups and 16 ice cubes. So yeah, looks like everything is working. All right. Okay. And you had customers today. Okay. So from there, now at the end of the day, we said as part of our game is that all the ice cubes melt at the end of the day. All right. So at the end of this if statement, we're going to say ice cubes equals 0. All right, so you always lose all your ice cubes at the end of the day. Okay, so what would you like to do? 1, 2, 3, 4, 5. Okay, so start the day. You had 20 customers today. You were able to serve all 20 customers. This is actually pretty good because we're going to have made 2 batches for this. So we should have lost 48 lemons. We should make $30 from it. All right, so we lost 48 lemons. We made $30. Ice cubes went to 0. Cups went down by 20. Sugar went down by 350. That is actually correct. All right. Now here's the thing. If it takes, let's do some quick math here. Right? Do we make enough? Right? From is the price set correctly? Now, in order to figure this out, what we're going to have to do is just go and do some calculating. Okay, so let's see how much it costs per unit to make a cup. Okay, so it takes 24 lemons and they cost 44 cents each. Okay, so it's $10.56. Okay, so $10.56 just for the lemons. All right, and let's see here. So $10.56 just for the lemons. Okay, and then we said it takes 1.75 cups, so 1.75 times, and it's 0.28 per cup of sugar. So that's going to be 49 cents worth of sugar. 0.49 plus, all right, let's see, we also need, it's 3 cents for ice cube, and we need for 1 cup. Okay, now actually, this is per jug. So we'll calculate the per jug cost. So 0.03, I don't even need that. We need 20 of them, so that's 60 cents. So 3 cents each, so we need 0.60 cents for ice cubes, plus 23 cents per cup. And we need 10, that would make 10 cups. So $2.30 for the 10 cups. All right, so let's take a look. We got, let's start again here. So we have 10.56 plus 0.49 plus 0.6 plus 2.3. Okay, so to make 10, in order for us to make 10 jugs of lemonade, it's going to cost, or 10 servings of lemonade, it will cost $13.95, which, if we divide it by 10, is $1.40, about $1.40 per cup. Now, currently, we have the price set to 1.5, right? So, meaning it costs us $1.40 to make 1 cup, but it actually we sell it for $1.50. So only make 10 cents per cup. All right, we should actually write this down. It costs about $1.39.5 to make 1 cup. All right. So if you're selling at only a 10% margin, it means that you're not actually going to be able to make anything really. You're not going to really make any progress in the game. All right. So let's sell it to two. Let's move the price up to $2. Right. So if we make the price $2, then we're going to make about 50 cents per cup. All right. So that's actually a bit better. All right. And we can make it so the player can adjust the price later. Okay. And I'll show you some tricks with that. Okay, so we have the main menu choice is 2. Okay, everything seems to be set okay here. Okay, let's make it so we can have the player adjust the price. Okay, now first of all, I want to do a few things. So I'm going to change the main menu choice for the start the day to be 4. All right, I'm going to add a 2 and a 3 in between there. Okay, so here this will become option 4, start the day. Okay, so let's put in something like this. Set the price of lemonade. All right, so set the price of your lemonade. So we will just go and, as per usual, we will just throw in an else if statement here. Else if main menu choice is equal to 2. We will say cout. What will the new lemonade price per cup be? All right. Now, we got to be careful because the user could actually abuse this and set it to be negative or set it to be extremely high. We will deal with each of those in its own right in a minute. Okay, so what we'll do is we'll say int new price is equal to 0. Okay, and then down here we will say cout or cin new price. Now, we don't want them to be able to mess around too much. All right. Actually, we should also put a message here. The unit cost, let's let them figure it out. Okay. We don't want the user to put in a price below 0, although they can put any upward limit of price that they want. So what we'll do is we'll say, do this. Okay. As long as, while the new price is less than 0. Okay, so if the new price is less than 0, we are going to ask them again, right? So that they can't do it. And you can see that's actually very similar to what we did over here, right? To make it so they can't actually enter a number that's not correct. Okay, while new price is less than 0. Now, if they put any price they want, like if they put $100, then it'll actually accept it. Okay, so once we get out of here, then we'll say the price is equal to the new price. Okay, and by doing that, it allows our player to set the price. Now, there's going to be some penalties for that, though. All right, so the way we're going to do it is we're going to go to start the day, and the price will affect the customers. Okay, so what we'll do is we'll say price effect. Okay, so how do you make the price affect the customers? Okay, so what we're going to do is we're going to say if the price is less than or equal to 1, or let's just say less than 1.395, or let's say 1.395. That's the unit cost. Selling at less than cost. Okay, then what we're going to do is we're going to say customers is equal to customers times 3. Right, so if you're selling at cost, a lot of people you're going to get 3 times as many customers because everyone's going to see that this is such a great deal, and actually it's a penalty to you because you're actually losing money on it. Right, so if you're selling it less than the cost, then you're going to lose a ton of money. So you shouldn't sell it less than that. But it means you'll also get a ton of customers if for whatever reason you want to do that. Okay, else if. Now what we're going to do is we're going to have some random threshold, right? So the random threshold is going to be a number between this and twice as much. So we're going to say if the price is less than, let's say it's greater than 2.80. So meaning they've more than doubled the profit on it. And so then what we'll do is we'll say the customers is equal to 0. Okay, so if you double the price, basically no one's going to want to buy this. Well, let's say you go a little more than double the price. So if it's more than $3, right, then you're not going to be able to sell anything. Okay, so just no one's going to buy that because it's just such a ripoff. This will prevent the user from setting the value to be like, $1 million per cup or something like that. Okay, so what do we do with all the prices in between? Okay, so what we have to do is we have to actually calculate some price threshold, and this could change from day to day. Okay, now what I will do is I will say double price threshold. All right, and basically, well, good price. Okay, so we're going to say what is the customer going to consider to be a good price that day? Okay, so what we'll say is that double good price is equal to rand. Okay, so what we're going to do is generate a number between the minimum price, so 1.4. So now we can't do 1.4 because we can't use modulus on decimals like that. So we're going to say 140 is the min. Now the max we're going to say is $3. So 300 cents minus 140 plus 1 plus 140. Okay, so what this is going to do is it's going to generate a number between $140 and 300. Okay, but I don't want 140 to 300. So what I'm going to do is I'm going to take this whole number and divide it by 100.0 to make it into cents. Okay, now the reason why I have to do 100.0 instead of 100 is because this number here is going to be an integer. If I just say 100, then the computer will see an integer divided by an integer, and the result will be an integer, right? So this won't be exactly what we want. But if I say 0.0, it'll see an integer being divided by a double, and it'll give a double back. All right. So, all right. So we have the good price threshold. So what we will say is if the price is below the good price threshold, was a or equal to it, then actually we will just say if it's above it. Okay. Customers, so if we set it above the good price threshold for that day, the customers will equal to customers times 0.5. Okay, so basically you only get about half the customers for the day if you set it above that price. Now, what if it's none of these? Okay, then, well, if it's none of these, then nothing happens to the customers, right? And you just get the regular number of customers that you had for that day. Okay, so let's test this out and start the day. Oh, I forgot the semicolon. And let's see, customers. Oh, it's number of customers. Okay. Okay. So we're going to get some supplies for the day. We're going to set the price of lemonade to be, let's say, I don't know, $20. Okay, and start the day. Now we should have 0 customers. 0 customers, okay, and we lose all our ice cubes. So I'm going to have to say 1, 2, 3, 4, 5 to get more ice cubes. Now we're going to set the price something more reasonable. And I notice here we set the price of lemonade. I'll have to go fix that. So set the price of lemonade. And we will set the price to be, I don't know, something like $2.70. All right, what would you like to do? Oh, and we have a crash. All right, let's go fix those things. First thing is lemonade. Second thing is to go down and see why that happened. And I believe I know why. It's actually over here. It's because the new price was not set to be a double like the regular price. And so when we enter in the number, it creates actually an issue with how everything is, like the math is working probably. And let's see what happens. All right, let's see if that fixes it. So we're going to go to set a price of lemonade. So 2. How much will the new cup be? 2.7. Okay, and then 1, 2, 3, 4, 5. Or 1, 2, 3, 4, 5. And start the day. 10 customers, 10. All right, now we had a 2.7, so we should have made $27, which we did. And it actually looks pretty good. Let's try this one more time. 2, 3, 4, 4, 5. So we have 267. If it's $2.70 per cup, let's start the day. 6 customers, so 270 is 16.20. So I should make 283.20. That's where my money should go. Yep, there we go. Okay, so all right. Our money or everything is working now. So we are good to go for setting the price. The only thing I would change is just here is I would say the current price of lemonade is, and then put the price so they can see what the old price was. Now that that's done, what we're going to do is I'm just going to do one last thing before I leave it, before I leave the shell here. I'm going to add option 3. So cout. Now option 3 is going to be by upgrades. Now, when upgrades are different in that they are not really consumed. Okay, so there's a number of different things that you can do for different upgrades depending on the idea of your game. So I'll give you an example of how this works. So we're going to say else if main menu choice is equal to 3. This is buying upgrades. All right, so we're going to need a menu. And what we will do is we can just add it actually into the main menu here. So we can see we're going to want a little bit of information on here. Okay, so here I will say cout upgrades. Now, how do you get upgrades to show up? Well, that's a good question. Okay, so what we do is we actually create Boolean variables. Now remember, Booleans can either be true or false. So I'm going to create 2 upgrades for myself here, and I'm going to say Boolean freezer is equal to false. All right, so the first one is a freezer, and the second one is the Mr. Chow statue. All right, and they're both going to do different things. Now, at first, I don't have the Mr. Chow statue, and I also don't have the freezer, both of which basically make it so, basically they do different things. Right, so I don't have the freezer, don't have Mr. Chow statue either. Now, in the menu, what I would do is I would say if Mr. Chow statue is equal to true, then we are going to print out Mr. Chow statue. All right, and then also if the freezer is equal to true, then cout the freezer. All right, and at the end, we'll just put another cout end line just to space things out. Let's see if that looks okay. And somehow, oh yeah, just lost that there. Okay, so upgrades. Currently, I have nothing. All right, what I will do is I'll actually create a variable here called int upgrade count to count how many upgrades I have. Right. So what I will do is I'll say if upgrade count is equal to 0, then cout none. All right, so currently no upgrades. And I also don't have any ability to buy upgrades because I haven't written that into the code yet. All right, so now that I have it, now the reason why I changed it on the menu, okay, is because I want to be able to copy this to the other menus. Okay, just this section here. Actually, this is the part where it's going to say the store. So we will just need this section here. So just this. All right, let's just make sure the menu looks right. So none, I go to the store. Good, okay, and go back. All right, so the menu still looks consistent between the store and the main program. All right, so when we get to main menu choice 3, we are going to do the same thing. We're going to print out this whole thing. Same as the store. Okay, so instead of Linus's upgrades or Linus's Lemon Lab, we'll have, I don't know, Ursula's upgrades. All right, so when you're going to Ursula's upgrades, instead of option 1 being to buy lemons as it is in the store, we're going to say buy a freezer. Right, and we'll go make the cost of these things. Now these things should cost quite a bit. So we're going to say freezer cost is equal to, I don't know, let's say $100. And Mr. Chow statue cost is equal to, let's say, also $100. All right, now where are we going? So freezer, this will be freezer cost. Now, the reason why I'm doing 2 upgrades and in the store I only did 1 product is just because I want to show you different things that they can do and how to do them. So I'll buy a Mr. Chow statue. Okay, for Mr. Chow statue cost, end line, what would you like to do? And here we're going to have int upgrade choice. All right, and going here to upgrade choice. Great. Now we're going to say if, let's see, upgrade choice is equal to 1, that means they want to buy the freezer. Now, what we can do is we can make it so that the person already, if they already have this, then it's not going to go into it. So, and we can say freezer is equal to false. So they chose to buy the freezer and they don't already have it, right? Then we can go in and see if they can afford it and everything else. Okay, so first thing we're going to do is when we get in there, we're going to say if money is greater than or equal to the freezer cost, that means they can afford it. Then we will say money minus equals freezer cost. So we're going to take away the money and we're going to set the freezer to be true. Okay. Now the only way that this can go to else is if they don't have enough money. We're just going to say cout, you cannot afford this upgrade. All right. Now otherwise, what we're going to say is that now they can always choose this, right? So if the freezer is not, if the freezer is true, right, then we'll go into this else statement and it'll say cout, you already have this upgrade. So they can't buy it again. All right. And what is going on here? Looks like maybe a little scope issue. Yep. Oh, I didn't finish the do while. While upgrade choice does not equal to 0. All right. So we're going to go try and buy upgrades. So 1, 2, 3, 4, 5. Buy upgrades 3. Now I can afford the freezer because I have 140 bucks. So buy the freezer. Okay, and there we go. We have, now here's a problem. It says none. And the reason why it says none is because our upgrade count did not go up. So upgrade count plus plus. All right, so we gained an upgrade. Okay, so 1, 2, 3, 4, 5. Let me bring this into the screen for you. Okay, so buy upgrades, 3, 1, buy the freezer. Okay, the money went down by 100 bucks, but you can see our upgrade went to includes the freezer now. I should take away this period there. Don't really like it. And then I'm going to choose 0 to come out of this. All right, and yeah, there you go. Now it says I should have the freezer again. Okay, so let's take that away. Where is it here? Mr. Chow statue, freezer. I gotta change that in 3 spaces in 3 different places. And here as well. All right, so that's basically how you can get them to purchase upgrades. Let's go to include the Mr. Chow statue. So basically the same thing. So we're going to have an else if. All right, so if the upgrade choice was 2 and freezer is equal to false. So if the upgrade choice is 1 and they didn't have the freezer, or they did not have the freezer, then you can go here. If the upgrade choice is 2, then we can have the freezer, or not the freezer. Then we got to check for the Mr. Chow statue. So Mr. Chow statue is false. Then money is equal to, we're going to check the Mr. Chow statue cost. Sorry, I got distracted for a moment there. Mr. Chow statue cost, the Mr. Chow statue is equal to true, upgrade count +1. Okay, now the problem is that if the user goes, this is where I got distracted here. So I can buy the upgrades. So let's go 1, 2, 3, 4, 5. Let's give me, I'll do it twice to get $200. So it's over 200, so I can just buy both upgrades. So 3, let me move this into the screen so you can see it. Okay, so here I can go buy a freezer and buy Mr. Chow upgrade. All right, so there we go. Now the problem is, let's exit out. 1, 2, 3, 4, 5. Okay, so I have enough money. Go back to upgrades. Right, if I choose 1, okay, it says you already have this upgrade. If I choose 2, it actually says that as well. But if I say 3, 4, it also still says, you can see it flash on the screen. I'm not sure if you'll be able to see it. Let's throw in a system pause there so people can see it. Okay, now the problem is that it will always say that even if the person didn't try and purchase those things. So what we're going to have to do is have if upgrade choice was less than 2 and upgrade choice was greater than 0. So meaning they chose to buy something that they could actually get, right? So they chose to buy it, and they just for some reason and they didn't have it. So if I chose 1 or 2, this should actually be less than or equal to 2. All right, so they chose to buy it, they did not have it, they chose to buy it, but they did have it. So it did not go into here, did not go into here, so it'll go into here. All right, let's see. And why did it not like this? Upgrade choice. Oh, upgrade choice. There we go. Okay, so we're gonna 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. All right, so we got $300. We're gonna go try and buy upgrades. If I press 3, you can see nothing happens now. All right, if I try and buy the freezer, I got the freezer. If I try and buy it again, you already have this upgrade. If I try and buy the Mr. Chow statue, I got that. Try and buy that again, I already have this upgrade. Okay, and back to 3 and 4. Okay, so you just cannot buy them over and over again. Okay, now that that is all set, we can go and look and see what those things do. So at the end of the day, so we're going to go into main menu choice 4. At the very end of the day, you can recall that we set our ice cubes to be 0. And what we'll do is we'll say if the freezer is equal to false. Okay, so if you have a freezer, if you do not have the freezer, okay, that's what that means. Freezer false is not, it means you do not have the freezer. Then your ice cubes turn to 0. Otherwise, okay, else your ice cubes, let's say you even make more ice cubes. So you get like, I don't know, let's say this small freezer, so you have like 30 ice cubes. Okay, so ice cubes plus equals 30, so you get 30 more ice cubes. All right, so let's say for instance, well, let me just review here. So that's going to show you basically how you can use this Boolean, right, to simulate whether or not you had an upgrade. Okay, now what about the Mr. Chow statue? Okay, so the Mr. Chow statue, I have a different idea. So what we're going to do is we're going to have the number of customers generated. Okay, and the problem is that, well, you'd like to be able to boost your customers. Okay, so what we're going to do is we are going to go and we're going to do something called the Mr. Chow effect. Okay, and all we're going to do is just say if Mr. Chow statue is equal to true. So if you have the Mr. Chow statue, then the number of customers times equals 1.5. Okay, so you're always going to have 50% more customers if you have a Mr. Chow statue. Okay, and it's just something really simple. You can get really creative on what these different things can do. Okay, so end Mr. Chow effect. All right, last thing. Sorry, this one just popped into my mind that I had forgotten. Okay, so we're going to change menu choice to be 5 for start the day. So 5. And last thing we're going to add is we're going to add in changing locations. All right, so for changing locations, okay, so we're going to go down to one. You technically don't have to write these in any order. I just like to write them in numeric order because it makes it easier to find them later. Okay, so we are putting in number four here. So we're going to say else if main menu choice is equal to 4. Okay. So in order to change locations, what we have to do is we have to assign an integer for each location. So we're going to say int location is equal to 1. Now, location 1 is always going to be, like, let's say your mom's house. All right, so we will have something like this. System CLS to clear the screen, cout, something like current location, and I'll just build one extra location. Current location if location is equal to 1. We're going to say cout mom's house. Else if location is equal to 2, then cout, I don't know, let's say you go to the park. Okay, so we can go to mom's house or the park. What we will do is we will have our location menu, so cout 1 mom's house, end line, cout 2 the park, end line, cin, cout, we're going to ask a question here, so cout, where would you like to set up your shop? Okay, and we're going to say cin, say do this. Now, whenever we take input, you always have to think that the user might want to mess with you or do something wrong, right? So what we're going to do is we're going to say, well, what if they don't put in a 1 or a 2? Okay, well, what we're going to do is actually, we're just going to trap them here. So they cannot get out of this until they put in a 1 or a 2. Oops. Let me just fix this up here. There we go. And we'll need that system clear screen as well. All right, so what I'm going to do is I'm going to say int new location is equal to 0. And we're going to say cin new location. All right, so what we're going to do is we're going to say while new location is less than 0 or new location is greater than 2. So if they did not enter, if they entered something below 0 or greater than 2, I'm not going to accept that. And I'm only going to change the location to be equal to the new location if they can get out of this loop. All right, so let's go try and change locations for current location, mom's house. Where would you like to set up shop? So let me push this in here for you. 2. Okay, now change locations. 4. Current location of the park. Where would you like to set up shop? Mom's house. Okay. Now, it would be nice to be able to set things up here, like in the main menu, so people can actually see it. So let's go after the upgrades. We'll include that as well. See out location. Actually, we already have that code down in the change location thing. So current location, we'll just grab that and paste it into our main menu. Current location. Okay, so I'll put an end line there. I think that'll make the spacing look a bit nicer. Let's just test it out. Current location, mom's house. Yeah, looks okay. So we're going to copy that and paste it back everywhere else. Okay, I think there's 3 different places where this menu is shown. Yeah, here's the last one. There we go. Okay, so change our location as our mom's house, so change location, go to the park. Okay, so now location says the park. All right, and so our user has basically all the information they could need here. Now, what do these things do? So what we're going to do is we're going to go back to start the day. So start the day is we're going to say if location is equal to 1 or is equal to 2, which is the park, then we're going to have to say money is equal to money minus park rent. Okay, so they're going to have to take away the rent cost for the park. Okay, now there is no rent cost for mom's house. Okay, actually, there's an easier way to do this. So we're going to say int constant int park rent is equal to, let's say it costs you 20 bucks. So you need a 1-day license for 20 bucks to set up at the park. Okay, and we're going to say int rent is equal to 0. So currently your starting rent, let me just throw that up here so we don't have like millions of lines of variable declarations. Your starting rent is going to be 0. And so down here in the main menu choice, we can just say money minus equals rent. So this way, it actually doesn't matter where you go, you always just take away rent. Now back at the park menu here, or where we choose things here. Here we go. Nope, option 4. Okay, so we're going to have location is equal to new location. And then what we'll do is we're going to say if the location was equal to 1, so they went to mom's house, then the rent is now 0, so you don't have to pay anything. The customer min is now equal to 0, and the customer max, I believe we had it set to 20. Okay, now else if the location is equal to 2, so they went to go to the park, then what we're going to say is the rent is equal to park rent, right? However, the customer min is equal to 10. So you're going to have more customers by going to the park, and your customer max is equal to, let's say, I don't know, 35. 35. So now you have actually way more potential customers to get by going to the park, right? And what that does is it affects the customers down here, right? So in the main menu choice, right, then when we generate our initial customers, because the customer max and min have changed, right, then we're going to create a different outcome from being a different place, right? But what happens is then they also have to pay a rent to be there. Now, this is going to have to be balanced. You're going to have to play the game for a bit to figure out what numbers actually work with the game, so it's not just totally broken by going to a certain area, right? And I believe that that is essentially it for the shell of the game. Now, this is just basically for a Lemonade Tycoon game, and it's not even complete. There's still a lot of other things happening that you can do, and I will actually try and come up with some other videos to show you ways to make some of these things easier and to clean up the code a little bit. Some of this will be more advanced stuff, but I encourage you to watch it if you have the time or the inclination. That's it for now. Please leave any comments you have in the comment section. Please remember to like and subscribe. Thanks for watching, and I will see you next video.